Yeah, welcome from my side. I'm Matthias Gessenay. I'm working for corporate software. I'm from Switzerland. Happy to meet you here. Let's have a great time. We will build our first AI model in the cloud. To be honest, we will build, if everything goes fine, two models today in this 45 minutes. I'm working as a trusted advisor and cloud architect since many years, and I'm a Microsoft MVP, Microsoft Azure MVP. If you want to try to contact me, here are my details. So let's start. What's the agenda? Um, I will give you a short overview about the architecture that we will build, and then we will start with the kind of perfect flow, which is a very simple but yet capable AI model. The first AI model that we will build is purely visual. I have prepared everything a little bit. So because AI training takes some time and waiting is not, well, the time is too dense that we should wait. Yeah? So everything is a little bit prepared, but we will always do some steps manually, and I will explain everything that we have is already done. So we will build a perfect flow, and the perfect flow is that we will predict used cars prices. So we have used cars in the list, and we already know the prices from that cars. Then we will remove the price column, and we will train an AI model, and then let the AI model predict how the AI model thinks is, and then we can compare the real price with the predicted pricing. So that's our first model. The second one is then the function that can see. There we will build an AI model that can recognize images from Simpsons in our case. And then the result is that we can ask which Simpson picture is that, and it will predict which one it is. Yeah, so these are our two tasks for today. So let's go ahead. So this is like the perfect machine learning walkthrough, perfect AI workthrough. So we have data, training data. Yeah? First we need to clean the training data. The training data is not perfect. We have missing columns. We have bad rows for, we have different data. So something is in percent, something is integers. We have sometimes, for example, cents and sometimes euros and so on. So we need to make this data as clean as possible, but yet we need to take into account that we don't want to provide perfect data unless we will get perfect data in real world scenarios later on too. So there's no meaning in that we train the model to assume everything is perfect, and then in real world nothing is perfect, then the model will fail. Um, so we clean the data up as much as we should, and as we think that should make sense. And then we will split the data. Splitting the data is important because we need training data to train the model, and we need data to check how good the model performs. So if, let's say, we have 100 rows, then we would split it, let's say 70-30 or something like that. So 70% is for training and 30% is for checking. So then we can check if the column, in our case, that we want to predict the price, if how the model performs. And we can add a randomizer, so-called random seed, onto that splitting. That means every time we will run the model, the split will be different. Yeah? That ensures that we can test the model's behavior with different data sets, not always the same. What's the problem with always the same? Always the same means that we can make the model almost perfect. So let's have a very, very high price prediction, yeah, so 99% or something like that. But most likely then we are in the area of overfitting. The model is perfect for this data, but will fail more or less completely on different data. Yeah? So that's why we don't want overfitting. So then we train the model. That takes a little bit of time in our case, because in the first example, we don't have so much data. This will not take so much time, so we can do it live. For the second example, this takes about I don't know, 10 minutes around that, and that's a little bit too long for our session. So I have already pre-trained the model. We can retrain it and see how it works, but I have already trained it, right? And then we do the scoring, as I said, with the splitted data. So how does it look like? It's in Microsoft Learn, part of Microsoft Learn, the tutorial here. So I put the link in here. If you want to do it on yourself, feel free. It's pretty nice. My promise: get started today now with AI. You can do it. Yeah, here's the link. So let's switch to our authoring canvas here. To make it a little bit transparent, I'm in an Azure Resource group, Global Azure, and I have created an Azure Machine Learning workspace. And now I'm in the studio, which is like the web interface. And there you're good to go. The only thing that you need to provide is a compute resource. I have already created that because of the sake of time. This takes about 5 minutes. That's a virtual machine where you then can submit, or container where you can submit the model for training, right? So you need some compute backend in the end. We can preview the data. So we started with the automobile price data. On the left side, let's remove the filter. We have some sample data sets. You see we have 16 sample data sets here. I have picked the automobile price data raw data set. We can preview the data. And you can see we have here normalized losses. It's not important for us now. That's why we will remove the column later. We have the make, we have the fuel type. Obviously, I don't think we have electric cars here. No, we don't. But that's fine. It's used cars. It's okay. Number of doors, body style, drive wheels, engine location, wheelbase, length, width, height, curb, engine, and so on. Yeah. And last but not least, the price. And the question is, can we create a model that predicts us the price? So if we want to sell used cars or buy used cars, then we need only these things like city MPG, peak MPG, horsepower, and so on, and we can offer a pricing. So that's basically the idea. When we go through it, we will see that we have some non-perfect data. You see it here. There are missing values from time to time. Yeah? So let's clean up, basically. First one, I don't want to set the parameters. Settings, here we go. So, yep, it's a little bit small. Let's move over. There we go. So, okay, parameters. Yeah, that's fine. First one is we select the columns in the data set. So we remove the normalized losses, right? So we simply say by column, we add all columns and remove the normalized losses, because the normalized losses doesn't help us at all. Yeah? So we say, okay, we only want that columns in the data set. Then we clean up missing data. We are a bit rigid there because we clean up everything that has at least one missing value. So if there's one column missing, we skip the entire row. Fairly simple. And then we split the data, and you see these items are connected. I see it here. Sometimes the steps have two exit points. Yeah. So you see, for example, here when we split the data, 70%, then the 70% goes on the left side, left bubble, and the 30% are going on the right side, on the right bubble. So let's submit that to our training job. I have it here. So it's submitted, it's running now, and it's done. So we can check here what's the result. Where we go? Okay, that does look fine. So let's move on. We now need to train the model. So, oops, what's that? I did something wrong. So, excuse me. Let's switch back to the designer. So, okay. There we go. So, I don't know. I went somewhere. I shouldn't. So, let's go to train model. Train model. There we go. Here's our action. And now we will connect the train model with this one. And we need a training algorithm. In this case, this is a linear regression. There we go. And we will connect the untrained model with the linear regression. There we go. So that looks good. And we need to set the label column. Yeah, oh, that's a bit weird. So yeah, label column. So which column? It's a little bit big, but then you can read it better. Which column we want to predict? This is the price. Okay, so let's go with the price. I think the price column is correct. Let's check it here. Need to move it away. There we go. So if we have preview data, it's the price column. There we go. Okay. Good. So now we have train model, and the next thing that we need to do is that we can run the training. So let's submit. Let's see how it works out. If it takes too long, we can leave it for now. Column name price. Pipeline is submitted. And you see the areas that were already calculated are now grayed out, and the one that are now done is split data, train model, and linear regression. So it's running, submitted, and well, we can go on in the meantime. So let's then score the model. Score model. Yep, there we go. And let's check. Oh, I can create a little bit more space here. Let's connect the score model with the train model and the 30% data set on the right side. So there we check how the model does perform, and then we go to evaluate model to get a little bit more statistics on that. And with evaluate model, you see we have a second bubble, so we could connect a second tree. So if, for example, we want to see if the linear regression model is really the one that we want to go with, or if there is a better one, then we can build the exact same tree and then work with a clean data set on a second training or with a split data and compare that. So we can even compare two different approaches to machine learning. Okay, so let's see. Completed, that looks fine. So we have now a trained model. And we can now run the whole thing and score the model. It's now running and scoring. Okay, it's still running, as I said, but we can do that live. If it is done, then we can right-click on score model and see the result. Now we can go here also to job details. Then we see, yeah, thank you for that help. Then we see how it works, and you see currently it's working on score model and then evaluate model, but evaluate model is pretty fast. Yeah? So everything else is already done. So let's check here. There we go. So preview data. You see, we can see the scored data set here. Yeah. and I can make it a little bit larger so it's easier to read. Yeah, we can see some statistics here. See that, right? But most important, we want to see the price. And well, this is the original price, but this price was used only for training, not with the data set that we now do for scoring. So the 70% were for training, 30% were for scoring. Yeah. Now this is a scored label, and we see this is a predicted price. So for the first car, it's pretty nice. Yeah. Second car is not so nice, but the third one is again pretty okay. Yeah. So we have some statistics here that we can see the model in general performs nicely, and for the cars where the model is not really good, we could now check if they are a little bit kind of special. Yeah. So special for cars, for example, could mean that if you have a very old car, then the pricing after some decades goes up again. Yeah. So if the car gets older first, the pricing goes down, and at some point it goes up again. So this, for example, will be a case that the model is not aware of. So it will predict almost nothing, while a 50-year-old car is worth a lot again. Yeah? But in general, it's pretty okay. So we can now go back to our model here. And we have then the evaluate model, evaluation results. There we go. And we have again some statistics here. Yeah, we have the mean absolute error, where we see, okay, how many errors do we have in general between the predicted value and the actual value. Yeah, so average of absolute value. So in average, this is the distance of the predicted pricing and the original pricing. Yeah. Then we have the relative absolute error, and the squared error and some other stuff. Yeah, that makes the correlation a little bit easier. And we have the coefficient of determination. This is the R-squared value. Yeah, so that means how well fits the model that we have created the data. And you see here it's 0.9, so it's pretty high. So we shouldn't get higher, then we would go into overfitting. If this would be 1, then of course this would be 100% match. Yeah. So we have 90% match, which is really good for that, even for that simple model. But of course, it's also quite simple data, to be honest. But you see, we have built our first model in about, I think, 20 minutes, and it works. And you can do it on your own. So if you want to head into AI, that's the easiest way to start with. So let's go back to our PowerPoint. Okay, next, training with images. Some words about the environment. So first, I will work with Visual Studio Code. Yeah? Visual Studio Code will do an SSH connection in the backend to an Ubuntu VM. This could be also a container. I took a VM because it's a little bit easier to fix something, and at least this is the demonstration, so it should work. Yeah? The cool thing in Visual Studio, you can simply create an SSH connection, and then you can execute code on the remote side. Very, very simple, very clear. You can even install modules on the remote side that are executed, but of course not everything. So some basics like Python, Azure CLI, Azure Function CLI must be already in place. Yeah? So that you need to bake in either in your container or in your virtual machine. So that's like the infrastructure setup. So how is the experiment set up? Huh? So on the left side, the Jupyter is like OneNote for data scientists. Jupyter is a notebook where you can mix code with comments, and you see also directly the output of that code. That's pretty cool. I will show it you in a minute. This is more or less the visual canvas from the Azure Machine Learning Studio that we used some minutes ago. Yeah, so that's the equivalent. There we execute some Python code, not very complex, to load training data. The training data is a Simpson Lego data set. So these are Simpson figures, Lego Simpson images, and these images are pretty different. Yeah. So the same Simpsons figure, one time with a neutral background, one time with a little bit mixed background from the side, from the bottom, different lights, and so on. So it's like if you want to recognize your fingerprinting on a computer, you need to put that in different angles. And it's a little bit like that. You present the same object in different angles, so the computer, the AI, can create a model out of that figure, yeah? Out of that Lego data set. And then we train a model pretty similar than we did before, but now this is huge, much more complex, yeah? As you can imagine. So we need a good service for that, and we will go with cognitive services. It's a service running on Azure by Microsoft, and there we will use the custom vision model. That's built exactly for that purpose. You have speech models, you have all the way down different models, and you have also a vision model that's for vision. We will use the general model compact. Compact means that the resulting model, which is a file, yeah, it's pretty small. So this model is optimized for sizing. Why it is important for us that it's quite small, as it means that we can download it as a file, ONNX, and that file then we can upload again to Azure and put it in a function, in a very simple function that calls the model and checks and uses the model so you can basically push in an image, yeah, to that Azure function, and the Azure function will ask the model which Simpson figure is that, and then give back the result. So that's the thing, yeah. And there a small model helps, because a big model is hard to transfer and hard to query. Small model is much nicer for us. And the main point is the training takes about, I don't know, 10 minutes, 15 minutes, depending on compute size here. Yeah? But for larger data set, it takes hours and days even. The function, just querying the model, the calculated model is blazing fast. It takes milliseconds. Yeah. So once you have trained the model, then using the model is really fast. And that's what we basically do here. Yeah. So let's go through the components. So first, what is Jupyter? Open source web-based interactive computing environment, typically used for Python, but you can also use it for R and Julia. It's a combination of live code, of visualizations, of text that you put in, so you can type your comments. You can even put in multimedia content. You can share them. You can edit them in a collaborative way, as I said, like OneNote for data scientists. And it's interactive, and you can also run it in the background. So you can even build batch jobs or background jobs in a notebook, and then, of course, not the text is executed, but only the code. I will show you in a minute. Next, we use Visual Studio Code. It's a lightweight source editor. It supports a lot of programming languages. You have syntax highlighting, code completion, debugging. You have a huge amount of extensions, including famous things like GitHub Copilot and so on. And I think it's one of the most used IDEs in the world at the moment. That's really, really cool. We will feed our data into cognitive services. It's Microsoft cloud-based AI services. It's easy. It's optimized models. They work really well. You have vision, you have speech, language, knowledge, search functionality. You can do voice interactions. You can do text analysis. You can do image recognition. And it's, of course, scalable. It's built on the cloud. It's built on gigantic data centers. And it just works. And so we use it. But you can train your own model with cognitive services, of course. And as I mentioned, we will then download the model as ONNX, Open Neural Network Exchange Format. It's the interchange model across deep learning frameworks, it's a neutral interface, so you can use it cross-platform. I could also execute that on a Raspberry Pi, but that's not so helpful when doing an online demonstration, as you can imagine. Edge devices, cloud servers, you can execute that on your mobile phone if you want. Everything will work. It's also so you can share it with the community, right? And in the end, we will use an Azure function, serverless compute. Serverless, of course, there is a server in the backend, as you can imagine, but you don't have to care about the server. The server is just there. If you need not very much horsepower, it will deliver. If you need huge amounts of horsepower, it will scale up and deliver. You pay only for the amount of compute that you really ask for. It's triggered by events, timers, whatever. We will trigger it by an HTTP call. You are built by execution time, and it's really flexible. So and it's pretty cheap compared, for example, to a VM running 24/7. So let's go to our demonstration, and let me go back. I will start with Visual Studio. There we go. This is Visual Studio. I always put a print hello world at the beginning, but well, let me introduce to Visual Studio. So this is Visual Studio. We have on the sidebar here, we have different areas like search, like the documents, like source control, debug, plugins. Plugins, really cool. Yeah, see it here. And Remote Explorer and testing and so on. Yeah. On the right side, we have the content with different tabs and all that stuff. On top, we have a menu, but in the end, most of the interactions are done with shortcuts. You have the command palette here, and see you have a bunch of actions. So really cool. On the top left side, you see that we have a green box stating that we have an SSH connection. This is our SSH connection. We are already connected to the Ubuntu machine that we that we have running in the background. So I could also show you a terminal, new terminal, and you see we are here on global Azure Ubuntu. This is my Ubuntu machine running on Azure, of course, and I'm in there. I can run HTOP or you name it, whatever. Of course, there's not much going on, but this is an SSH connection. And I can install plugins on the remote machine. You see it here? I have already installed some stuff like Jupyter that we need here, but I could install more nodes, Power Platform tools, whatever. I can go here and say install in SSH, and then the plugin is installed on the Ubuntu machine. That's really cool. But not our topic for now. So, okay, so let's go. First one, we will download the Simpson data set on the virtual machine in the path data train. So on the Ubuntu path in the home area, there's Ubuntu train. And you can see it here. I have, give me a second. I will move it. Oh, Explorer is thinking about something. Yeah, so I can show it. This is the training data. You see that we have different images here. Let's go to Homer. And for whatever reason, it takes some time here to load. But you see we have, some images, 51 in this case, from Homer. And so for every Simpson person, we have personality, we have this amount. So I have already executed everything here because of the sake of time. And I have already copied the model to the function. So nothing can go wrong. We can simply execute that stuff. And I have, as you can see, on every cell, you see, we can add code or we can add markdown. Markdown is text and code is code. So and if I run that cell, then the first one you see the outcome is hello world, and here's the outcome, the output data extracted in, download file removed. Next one, we import the different pip modules. And you see, this is our endpoint training key. No, don't worry, this will be removed directly after the lab. So, we will connect to that thing, and then we will output the training domains. These are the different models that we have, and you see, we will go with the AB5 model here. And this is just an outcome where you can see we have different models that we can go with in that vision module. We are already connected to vision. Yeah. So we will go with AB5. This is a general compact model vision. And let's go. I don't. This was simply debug code. We can go ahead. We create a project, a new project, and then we collect our images. Yeah? We batch our images. There we go. Then we upload our images to the model. This takes a little bit. So done uploading. Next one is training. I will start training later, but since I have already trained the model, it should work. That we simply skip that. And here you see we create the ONNX. Oh yeah, I need the iteration here. Yeah. But I have already done that. Let's see. Yeah. Okay. So we need to do the training. No worries. You will see there's an status every 25 seconds, and we can keep it in the background. And I will go visually through the next steps. So next we download our ONNX to the virtual machine. So it's sitting simply on the virtual machine. I can navigate here. By the way, you see it. Yeah. This is data test and data train and models. Let's go to model, and you see that the model ONNX. This is the thing I've already created. Yeah. And now it will recreate, retrain because we have created a new project. So it will retrain the cognitive services, which is fine. And then last but not least, we will download the test images. This is a different data set, exactly as we have with, this is a splitting, right? So we have the splitting pre-done into different zip files, but it's exactly the same we did before with the studio, 70-30 split. And then we ask the model to classify that images. So we can do that later when the model went through and predict which Simpson characters it recognizes based on the test images, data test. Yeah. So at the moment, model training is running. Let's hope that it work. I think so. I hope I started it. Yeah, it's now 1 minute. So let's keep it running. 25 seconds several times. And we can now jump over while it's training to our web browser. I have prepared a web browser somewhere here. There we go. And you see, I can call, I will show you the Azure infrastructure later. In a minute, I call our function Azure Websites Net, API classify, and then I provide a URL to, I did it wrong, let me go, to BART. And so I simply ask for BART. Now I didn't call the function for some time, so it takes a little bit to wake up. And you see the result is I'm 35% sure that I see Bart Simpson in that image. So that's a function. Let's have a look on our Azure infrastructure. There we go. So yes, this is a function. So this is a resource group that I have here. And we have the virtual machine. This is the Ubuntu virtual machine, of course. We have the custom vision. We cannot really see much on that custom vision. Yeah, it's like regarding the user interface pretty closed. We have the machine learning workspace that we have already used, and we have our function. So this is the classify function. If you remember the path, I can show it to you again. Azure Websites Net API classify. You see it here, it's classify. So when we go to the overview, you see here, this is the URL, global Azure Simpsons Azure Website Net. Yeah, and then the function is classify. So I go to the classify function, and there I see some statistics on that. Yeah, I can see it here, but the function was created in Visual Studio Code, so we can view it only in Visual Studio Code. You see, hey, yeah, training is complete. So let's move on, and I will show you the function in a second. So we can download or export our model. It's running now. Takes a minute. Yeah, it's done. Next, we can extract the model in data. That's the model in model and the directory model. Yeah, that's also done. And now we can download the test data, and then check how the model performs against our, you see it here, our different images. Yeah. So image lisa.jpg maps to Lisa Simpson, labels with 70%. Millhouse maps to with 46% to Millhouse. You can question, okay, why 46%? Maybe because the image is a little bit special. Yeah. And we can go here to our test function. So let's open that, and I can, I think, show it to you in that way. Okay, no preview for whatever reason. So let's double click. Okay, it's loading. Everything is a little bit slow today, but that's fine. I moved it away. You see it here. Yeah, and you see that's a pretty tricky background. Yeah, there's a finger. It's not so nice training data and test data, which is okay. Yeah. So what did we have a second ago? Let's go to Visual Studio Code, where the classification Millhouse was it? Yeah. So let's have a look at the Millhouse image. Yeah, you see it here. So it's pretty hard for AI, but it works. That's okay. Homer, it maps to Homer Simpson. Flounder, it maps to, yeah, and you see, okay, that didn't work. Yeah, that image was too scary. Let's have a look here. There we go. Yeah, you see it's blurry, huh? So that didn't work. And Marge Simpson is again really nice. Huh? And so last but not least, let's go back to our function here. So this is the function. You see, it's really short, yeah, for that, and it simply takes the image, makes a resizing to make it pretty small. That's quite common because big data with machine learning is really hard. Takes a lot of compute resources. And then it makes a label, and it finds a label with a higher score. So I could also produce the output. Okay, this is with 70% this person, and with 50% this, and so on. Yeah, and then there is a simple return. I'm so much percent sure that I see this Simpson character there. Yeah, so that's all. That's all, and it's really fast. It's blazing fast. Because I have pre-trained the model, of course, and they simply put it in a function. So, well, that's a second, a little bit more complicated walkthrough. So let's recap. let's check if we have any questions, but at the moment we don't have any questions. So let's recap and let's see what we did. So I assume, there we go. We started with the infrastructure. I assume it's a little bit more clear now. If you didn't know that, you can use Visual Studio Code. You can connect with Visual Studio Code with SSH to an remote environment. In our case, Ubuntu virtual machine running on Azure. And so we trained the model on that Ubuntu virtual machine in Azure. It takes about, I don't know, 5 or 10 minutes. I haven't had haven't checked it now, but I think it was a little bit more, 5 than 10 minutes. And it's completely transparent. That's really cool. So even the Jupyter Notebook, of course, is stored on the virtual machine, but I can edit it locally. So what did we do? We used Jupyter Notebook with some Python code to download the images, to train the custom vision model on Azure AI, Azure Cognitive Services, and then we put in the training data. Of course, we let the training run. We downloaded our model as ONNX. We put it into a function, and then we let the function predict which Simpson character that is. And exactly the same thing we could do, let's go a little bit back, with our kind of perfect generic schema here: get data, clean data, split data, train data, score model. So when I go to our, there we go, to our pipeline here, yeah. And authoring pane, you see we took the automobile price data. We removed a column that we don't need. We cleaned all data that has missing data. Then we make the split. So the left side is the trained zip file on the image model. The right side is the test zip file on the image model. Then we trained the model. In this case, it's linear regression. So the part that is linear regression here would be cognitive services on the image model. Yeah? Then we scored the model and we evaluated the model. And the evaluation is in the end our test in the notebook and then the Azure function. And given that fact, we could also go and publish this model after we have computed it. You see it here. We could publish it here directly as an endpoint. Yeah. Let's create a new endpoint here. Yeah. Pipeline created somewhere, and so on. We can publish it, and then we could call that endpoint and give it the parameters. We need to define the parameters. I didn't do that for just for demonstrations and for time, but you get the idea. We could publish that endpoint, and then we could call that endpoint with the data that was most interesting for us, yeah, here in that model. And then we could call that model and get back the pricing. So you could integrate that in a very simple thing like a Power App or whatever, even in an Excel. Yeah. So you have a car buyer there typing in the 5 or 6 values, and then the model in the backend calculates the pricing for that used car. And I think that's pretty neat. And this is a low no-code experience here. Yeah. So I think that's pretty nice. And if you want to get started, I've put the link in the slide deck. Just go ahead. It's easy. It's very visual. Yeah. You don't need deep Python knowledge, but in general, it's not deep Python knowledge even for the second demonstration, right? But here it's a no-code experience, and you in every stage you can go here and access, for example, the score data set. Yeah. And so that's it. Thank you very much. I hope you enjoyed the demonstration. I hope you enjoyed the session and the Global Azure Bootcamp Austria. So have a nice day. Thank you for watching, and well, see you. Take care.